We are talking about graphing absolute value functions, and here we have the parent function f of x is equal to the absolute value of x. This is the most basic form of the parent function, and so the value out front of the absolute value sign, if there's nothing written there, it's understood 1. So that tells us the slope of our two lines, our two rays. So we go up 1 over 1, up 1 over 1, up 1 over 1. So that's the slope of these lines. Up 1 over 1, up 1 over 1, up 1 over 1. So when we get a number that's a fraction, then that's going to flatten our absolute value out. So here we have hk, and that is 1/3 times the absolute value of x. And so here we go up 1 over 3. 1, 2, 3. Up 1 over 3. 1, 2, 3. So that's the slope of that line. If we look at g of x, that ends up being more vertical than the parent function. So here we go up 3, 1, 2, 3, over 1. Now, we haven't moved the vertex. All these vertexes have all been at the origin 0, 0, because we haven't added in a h or a k to the equation. So now, if we look at j of x, we have inserted a h and a k into the equation, and so we have x minus 1. And this is actually backwards because there's a minus sign in the original equation. It's x minus h. So if we have a negative here, that means we just added in a positive 1. And here we have a positive 3. So that's this graph vertex should be to the right 1 and up 3. So our vertex should be up here. And then we don't have an a value. So actually, this graph has the same slope as our parent function. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. So we can manipulate it and we can kind of move it around. And if we put a negative value out front, if we put a minus 1, that ends up turning the graph upside down. So now we have a negative slope. So from the vertex, we go down 1 over 1. And anything that, if we put in a plus 1, that's actually, if we introduced a minus 1 into the equation, it shifted it from here over here because it went from the vertex of 1, 3. Now we're at a vertex of negative 1, 3.